Hey everybody, here's a couple problems from the homework that you guys requested. So 19, this is number 6 in the homework. It goes from 6 to the end, okay? So the first questions, or number 6 is asking find the geometric mean of the two numbers. So in this case, your geometric mean can be referred to as a over x equals x over b, or you could look at it as x squared equals a times b, which ultimately becomes x equals the square root of ab. So if I apply this to here, if 25 is my a, 35 is my b, so x squared is equal to 25 times 35, and then take the square root of both of these. So x is equal to the square root of 25 times 35. And we're going to break this down to get the easy, to get the simplest form. So I could multiply these two numbers now, but I'm going to end up breaking it up anyway. So I'm going to break this up now. 25 is actually a nice number, because I can take the square root of it. And then 35, if I think about 35, it's 7 times 5. I can't take the square root of either of those numbers. The square root of 25 is actually 5, and 35 is just going to stay right inside my radical. So the exact answer is 5 root 35. Alright, so same thing for this next one. This is number 8, I believe. This is going to be my a, this is going to be my b. So x squared equals 8 times 28. Take the square root of both sides. X equals the square root of 8 times 28. And I'm going to start breaking this up now, and I see that 8 is 4 times 2, and 28 is 7 times 4. So when I simplify this, I have a pair of 4's here. 4 times 4 is 16, and the square root of 16 is 4. I can't take the square root of 2, so that's going to stay inside my square root sign. Can't take the square root of 7 or break those up. Those are both prime numbers, so 4 radical 14 will be my final answer here. Alright, so same thing here. Here's my a, here's my b. So x squared equals 24 times 45. Square root both sides. X equals the square root of 24 times 45. I'm going to break up 24. 4 times 6 is 24. 4 is a perfect square. I'm going to break up 45. 9 times 5 is 45. That's a perfect square. I could break up 6 again, but it's only going to be 2 and 3, so I don't care. Square root of 4 is 2. Square root of 9 is 3, so I'm going to multiply those on the outside. Square root of 6 stays inside. Square root of 5 stays inside. I can break 6 up, but it's going to be 2 and 3, so that does nothing for me. 5, I can't break up, that's already prime. So this is just going to be square root of 4 times 5. So x is equal to 6 times the square root of 20. Alright, so this next slide is just a theorem that's in the book here. It's the right triangle similarity theorem. It pretty much says if you have a right triangle and you draw the altitude from the vertex of the right angle here, and you draw an altitude straight down, you're going to create 3 similar triangles. So this triangle in green, which is this one here in blue, this triangle here in blue is this one, and then the big triangle is the whole thing. All 3 of these triangles are going to be similar, which means that there's a ratio or a scale factor involved. So, like the smallest, this small side here, the bottom base here is similar to this bottom base, similar to that bottom base. So they're all a factor of one another. All right, and we're going to apply this in these next problems here. So these are the other problems. So I think we did 2, 4, 6, 6, 8. This is number 10 or 6. This is number 7, 8. It's probably 9 in your homework here. All right, so we're going to use this. So they came up with a shortcut here and said that the altitude CD here, if you square the altitude, it will equal the two bases, the product of the two bases. If that makes sense to you. Another way to look at this is with what you already know from 7th grade. So if you look at this, and you look at this triangle here. So again, all these triangles are similar. So I'm going to pull that triangle out. I'm going to rotate this for a second. I'm going to remember that this piece here is my y, and the other piece here is my 8. I'm going to rotate this way so I can look at it with this orientation here. So we said this is y, and this is 8. And then I'm going to look at this triangle here. Okay, and this this bottom piece here is my 5. So this is my 5, and this is my y, right? The orientation of it. And again, all I'm doing is going to create a proportion here, or a ratio here. So 8 times something is y, and y times something is 5. So, but they're sharing a common side, and this is what's going to happen. So if I make a proportion here, I could do any kind of proportion. I could do 8 over y. So I could do 8 over y is equal to y over 5. And that could be my proportion, right? I'm gonna make sure I stick to, and you could have done this a couple different ways, but I'm going to use this left side over that left side, and then my bottom over the bottom. Just make sure you go in the same orientation, right? So from left to right. And then once I'm here, then this just becomes a proportion that you guys solved last year. So you could do the butterfly technique. So y times y is y squared. 8 times y is 40. And then you take the square root of both sides, and you get y is equal to the square root of 40. You can simplify this. Y equals the square root of, I'm going to break this down in 4 times 10, and y equals square root of 4 is 2, so 2 radical 10. Alright, so again, and this is really just this formula here. Right, look what happens. CD squared. So this piece here is what they're referring to as your CD. So y squared is equal to AB times BD, which is 5 times 8, or y squared is equal to 40, and which is really just what I just did here, right, with the proportion. So if the formula doesn't make a whole lot of sense, try to get the rate, break out the triangles that you see, and make a ratio of, left, big sides is, these two sides, and the bases, the bottoms, whatever ratio, again, you could make a couple different ratios here, but anyone would work. And if you did the ratio correctly, you're still going to come out with y squared equals 40. So if I would use the formula here, this piece here is my CD. Right, this part here is my CD. So this is saying that 10 squared equals AD, which would be x, and BD, which would be y, or to be 25. So then I get 100 equals 25x, and then just divide both sides with 25, and you get x equals 4. That's one way to do it if you're using this formula. And I'm going to show you the other way if you were to set up the triangles. So let me just move this over. Bring that back in a second. So if I'm using the triangles here, I'm going to use code red. So I'm going to refer to this triangle here. Right, so bottom piece is x. Right, there's my right angle. This bottom piece is x, and this piece is 10. And then if I refer to this triangle, okay, the bottom piece here is so this bottom piece here is 10, and this piece is 25. Again, I can make a ratio. I can do 25 over 10 equals 10 over x. And again, if I use that butterfly technique, 10 times 10 is 100. 25 times x is 25x. Divide both sides with 25, and x is equal to 4, which is ultimately what I did first time, just using that other formula. The same concept. Alright, so this is the same thing here, okay? These were a little different, but again, you could revert back to the formula, and let me just get that real quick for you guys. Let's paste this on here. Okay, poof, magic, it's on there. Alright, so now they're saying, before we were talking about the altitude, CD squared, equals AD times BD. Now they're referring to a leg, and they're saying the leg CB squared is equal to the shorter leg times the whole longer leg there. And again, you could use that, and if you're trying to make sense of this from the formula point of view, is here's your CB squared, which is the leg, so CB squared would be your B, or CB would be your B, so you would have B squared equals and it's going to be the dB times AB. Let me backtrack a little bit on that one. The CB is the shorter leg, AC is the longer leg. When you're looking at this triangle here, B would be your longer leg. So I'm going to use this bottom one here. So this would be your AC squared equals AD, which this would be the 16 would be your AD times AB, which would be referring to the entire piece here, times 16 plus 6, which is 22. Again, if that doesn't like really click, make sense, let's look at it as a proportion again. So I definitely want this triangle here because it has the B. Alright, so if I take that, pull that out, this is my B and this is my 16. I can't use the smaller triangle here because it doesn't have any information here. So I'm going to have to use the larger triangle here. Right? Because again, they're all similar. So this large triangle has a side here of B and a long side of 22. So this is my B and this is my 22. That B should be here, sorry. So 16 is the leg, 16 is the longer leg of my right triangle, B is the hypotenuse, and if you look at this big, B is the longer leg of the big triangle, and 22 is the hypotenuse. So 16 over B, so leg over leg, equals B over 22. So then you're just left with B squared equals 16 times 22. Square root of both sides. B equals, square root of 16 is 4. Square root of 22 is just 2 times 11. You can't break that down anymore, so just 4 radical 22. I think the proportions, makes more, can make more sense if you're used to it. If you're able to learn these and memorize these and see how it works, it's not bad, okay? So when you're using, if you're using this first formula, if you have the shorter leg, it's the shorter leg squared times the smaller piece and times the whole piece here, the longer piece, right? And then vice versa, if you're using the longer leg here, if you give a longer leg AC squared, so then you're squaring AC times AD times AB times the whole piece there. And that's essentially what this B squared equals square root of 16 times 22. It's the same exact thing. But I'm going to do this with the proportions again. I think that makes a little more sense. So I have a leg of a triangle, right? I have actually the longer leg. So if I'm just to compare this, I'm going to use the formula first and then I'll go with the proportion. So I'm missing the longer leg here. The longer leg is AC. So I would say x squared equals, the whole thing is 8, so this piece is 6. So it's going to be x squared equals 6 times 8. So this piece, so the longer leg, it's going to be 6 times the whole thing, which is 8. And then I'll have x squared equals 48 if you want. X squared equals 16 times 3, which is 48. Square root both sides. X equals 4 radical 3. Alright, and now let's compare this with the proportions. Put this aside for now. Okay, so I'm going to use, I need this triangle here. This has x and 6, so the longer leg is going to be 6, the hypotenuse is going to be x, okay. So here's my right angle. The longer leg is 6, the hypotenuse is 8. Then I'm going to take the whole big triangle here. So now the longer leg is x and the hypotenuse is 8. So the longer leg is x and the hypotenuse is 8. Alright. So now I got everything I need. So now I can make my proportion. So uh, 6 over 8 equals 8 over x. 6x equals 64. Longer leg is 6. Oops, sorry. Oh, little mistake there. So for this red triangle, the hypotenuse is x. I wrote 8 by accident. Let me just erase that. This should be an x. Right, so there's my longer red triangle. There's my right angle. Opposite the right angle is x. And the longer leg here is 6, because 6 plus 2 is 8. So, okay, perfect. So now I'm sorry. So I have the hypotenuse. Get rid of this. The hypotenuse over the hypotenuse. So x over 8 equals the leg over the leg, which is 6 over x. And cross multiply, x squared equals 48, and we're right back to this piece here. Square root, x equals square root of 16 times 3, x equals 4 radical 3, which is going to be right back to doing it with the other method. But again, any method you choose would be great. Just looking at my diagram, this should be, the x should be here, sorry. Okay, so this is the next question here. It says, use the diagram to decide which proportions are true. Alright, so I'm gonna break this up. So I got this big triangle here. Alright, there's my big triangle. And I'm just gonna line these up so there's my right angle. Obviously, it's not perfect, but and here's ABC. So then I have this small triangle, a right angle here. So I'm going to flip that around and let's turn that left to right. So now D is the piece here, B is up here, C is here, there's my right angle. So now if I'm just comparing, you know, those two are proportional, meaning there's a scale factor that connects those two, these two proportional, and these two are proportional. And then the last one here is this one, A, DB. Let me steal this one out of here. And I'm going to rotate this one too. Flip this, that's right. Okay, and if I line that one up, so DA is the longer, and B is the shorter. So again, let me just highlight the similar areas here. So there's the red, there's the yellow, my hypotenuse, and there's my green. So AB, BD, and AD are all similar. There's some scale factor that connects AB to BD and AD. So if AB is the longest, I could get to AB by multiplying by a scale factor. For BD, I get to AD. So they're all similar. So this first one, so let's check this one. This one says DB over DC. So DB, so they're over, so DB is this side. So DB, I'm comparing this first one here. Okay, DB over DC. So they're doing a ratio of this green to this pink. So if I haven't even looked at the other side yet. So the next ratio would be true if I did green over pink, green over pink. So any one of those, either one of these would work. They're using DA, which is this one. So far, so good. And it should be DB, and it is. And that works. So check. Select all that, apply. Okay, let's put this one, I'll bring this over here. Okay, so the next one for B, they're doing BA over CB. Okay, so BA is my green here. CB is my pink. So as long as it's green to pink, leg, longer leg to shorter leg, I'm okay. CB. So now they're using this side. So they're using the same side. CB to BD. So they're using AB and CB. So they're using these. So they're making a ratio of long leg to small leg is equal to a ratio of small leg to small leg. That would not work. If you're going big to small, then you need another ratio of big to small, not small to small. So that doesn't work. So no B. Let's group this one. Oop. Sorry. Let's group this. That one did not work. That was part B. Part C is CA. So hypotenuse, CA, okay. Over BA, another hypotenuse. So they're going from this triangle to this triangle, so the large to the medium. So it's got to stick to large to medium, right? So I have to compare something on both of these. So CABA, so hypotenuse to hypotenuse, and then BA, long leg, should compare to the other long leg of AD. And does it? It does CA, wherever CA is. And that's not good. So, nope. No love there. And then the last one, D. DB. So where's DB? Okay, so short leg here. So DB, short leg over BC. So short leg, short leg. Okay, short leg to short leg, that's fine. But it has to be a comparison from this triangle to this triangle also, so I'm not using this triangle. And it says DA, short leg over the short leg, long leg over, should be long leg, and it is, it's actually BA, so that works as well. So 2 of the 4 work here. Okay, this next problem in the homework, modeling real life, this is actually pretty cool. I want to actually do this and try to figure out the height of this school with you guys. So you're using a square here, and you're looking directly at the square, and you're lining yourself up at the height of the sculpture here, and the ground, and there's some pieces, so you're creating a right triangle visually, and you have some information here, so, and you're trying to figure out this long piece here. So I have some information, so I have, if I'm looking for the hypotenuse here of this long leg, if you want to say. So I need some information. I need one of these pieces to give me a hypotenuse of something. So I need this piece here, because this is the hypotenuse, and in order for me to compare this triangle to another triangle, then I need some more information. I need the hypotenuse as well. So I can get this hypotenuse here, because the hypotenuse is just c squared equals a squared plus b squared. So we'll do a little work there. So c squared equals 7.2 squared plus 5.5 squared, and the square root of all that. And I'm just going to put that right into my calculator. So 7.2 squared plus 5.5 squared. Let's see what that comes out to be. I get about 9.1 if I'm rounding to the tenths place. Okay, so now for the big triangle, I have some information here. So for the, if I'm visualizing this big triangle here, which is this, right? I have the bottom base, which is 9.1, and don't know the height, I'll call that x. And if I compare this to another triangle that I have, I have another triangle here in green, and if I compare this green one, the hypotenuse is 9.1, and the bottom base here, the smaller leg, is 5.5. So now I have corresponding parts, and I create a ratio. So there's my bottom leg for both of those. There's the hypotenuse for both. So you can make a ratio of x over 9.1 equals 9.1 over 5.5. That's one way to do this, and you could just cross multiply and get 5.5x equals 9.1 squared, which is 82.81, and then you can divide by 5.5. And I'm at x approximately equals 15.1 feet. And just to go the other route, we have the hypotenuse here, or we have this leg here. So that formula before was x squared equals a times b, where this is your x, this is your a, and this is your b. So this would look like 7.2 squared equals 5.5 times the unknown here. I'll call it b for now, right? So this is a, this is b, and this is the altitude. So the altitude squared equals the product of the two legs here, a times b. And if you put, if you divide by 5.5 in your calculator here, you'll get b equals 7.2 squared over 5.5, which approximately equals 9.4. So this piece here is 9.4, and to get the total height, you're going to take that 9.4 and add 5.5 to it, and you get about 14.9. So similar, but we did it a little bit different here. So with a little bit of rounding, we're pretty close. We're about 2/10 off. So either way would work. I would take either way in this one. Let's look at the next example. So find the value of the variables. Alright, so let's see what we got here. So I'm going to create some proportions here again, or I'm going to use my formula here. So the formula again here is take your altitude, square it, and it equals the product of b plus 3 times 8. So this would be 36 equals 8 times the quantity of b plus 3. You can distribute the 8 or divide by 8, doesn't matter, so I'll just go 36 divided by 8 equals b plus 3. And then this just becomes 36 over 8 minus 3 equals b. And you can just simplify that. And you get b is equal to 1.5. Alright, so no big deal there. And that will give you the value of b. And there's nothing else here. Alright, and then here, okay, I'm going to go with the altitude. So the altitude squared equals x times 24. So I'm just going to divide by 24 on both sides. And x is going to equal 32 squared over 24, whatever that equals. And I'll just put that into the calculator. So 32 squared divided by 24. And I get 42 and 2/3 is my x. Alright, and then again I'm going to go with the formula here. Or I can go with the ratio. So I'm going to go with y. So that's going to be y squared. So leg squared equals 24 times all of this, which is 24 plus x. Which x now is, we know is plus 42 and 2/3. So I'm going to square root all that. And y is equal to the square root of 24 times 24 plus 42 and 2/3. And I'm going to put that all in my calculator there. So the square root of 24 times the product of, in parentheses, 24 plus 42, put a little fraction in there. Oops. Try that one more time. So sorry, 24 times 24 plus 42 and 2/3. And y is equal to 40. It's beautiful, thank you. So this one's 42 2/3, this one's 40, and then using z. So z squared equals first part of the leg, which is 42 and 2/3, times the sum of all of it, of all of this, 42 and 2/3 plus 24. Square root, z equals square root of 42 and 2/3 times 42 and 2/3 plus 24. Again, I'll just throw that right into my calculator and get that going. Let's see what we got here. So we got the square root of, put a fraction in here, 42 and 2/3 times, again, another fraction here, 42 and 2/3 plus 24. And I get 160 over 3, or as a decimal, 53 and 1/3. So remember, the answer key's online also on our website, but this is what the answer key will show you. Pretty much the same process I just did here. Okay, from top to bottom. Data plan style for x first. They got 42.7. I did 42 2/3, and they just went with that shortcut. Again, use the shortcut, if you're comfortable, or just create your ratios and put, build the triangles and create your ratios. All right, let's see if there's anything else we have to go over. All right, so the next one on the homework is this kite, and I'm looking for, you want to use a straight bar across BD, so you need the length of BD. So BD is your unknown. Okay, so I'm going to break this down into, I'm just going to look at half this triangle, right? So I have a big triangle here and some small triangles, right? And I'm looking at this one, and then I'm looking at this one as well, right? So these are the three triangles I'm looking at. All right, so let's see what we got. We got AD is 44.8. We got DC is 72, and AC is, oh, where is 84.
Hello.
Oh, sorry, not you. 84.8 going all the way across from here to here, right? That's from this is from here to here. So, and I'm looking for this whole piece here. Well, let me back up, and so let me just do, so if I just do this piece, let's see. If I look at this triangle, right, and I compare, so I have this triangle, I have the hypotenuse, which is 44.8, and this piece here is here, and I don't know. So if I could find that, I could double it and get this one, and I could get the whole crossbar. So I have this triangle here, so I need some pieces. Do I know this is my longer leg? So I have this big triangle, ADC. The longer leg is 72, and the hypotenuse is 84.8, and that was all given. So now I have exactly what I need, right? So I have I'm going to make a ratio of hypotenuse to hypotenuse and longer leg to longer leg. Awesome. So that's pretty much it. So I'm going to do 44.8 over 84.8 equals, so hypotenuse to hypotenuse, leg to leg. So then I'm just going to do 84.8x when I cross multiply equals 44.8 times 72, whatever that is. And then I'm going to divide by 84.8 on both sides. So x is equal to whatever that is. Then I'm going to plug that into my calculator. And I'm going to get about 38.0377 ... And then I'm going to multiply that by 2, because that's just half of it. And I'm going to get about 76.08 if I round to the hundredths, or 76.1 if I round to the tenths. Alright, so that's that. So again, you could do this with a ratio. You could try using one of your theorems, but I thought the ratio was easier than this one. Alright, another problem here. Let's see what we got. Use both geometric means to find AC and BD. So it says to use the geometric mean here, but to find AC, I mean, this is a right triangle, and you have your legs A, B, and you're looking for your legs C here. So you have a right triangle here, so you could do the Pythagorean theorem, which I would. But I'm also noticing a triplet here, right? This is 15, 20, and I'm missing my hypotenuse. But 15 and 20 are both divisible by 5. So 15 divided by 5 and 20 divided by 5, that's 3. This is 4. So this is a 3, 4, 5 triangle. So really all I'm doing is just multiplying everything by 5. So AC is just 25 units long. Again, you could have done C squared equals 20 squared plus 15 squared, and C squared equals 400 plus 225. C squared equals 625, square root of both sides, and you got C equals 25. But I did notice the triplet here, so 15, 20, 25 is the triplet. And then it says find BD, so that's how I would find AC. BD you would have to do a little more, so BD again you could do a couple ways, but the theorem was BD is equal to or BD squared is equal to AD times DC. I don't have them individually here, so I'm just going to make a big triangle here and just set up a proportion again. Again, I'm not going to tell you to use the geometric means here. I just do whatever, do it how you see it. ABC, so AB is 20, BC is 15, and the hypotenuse here is 25. And I'm looking for BD, so here's B, D, and there's C. So BD is my unknown here. C is 15, so now I have enough pieces here, so I have hypotenuse, and a leg and a leg. So there's my proportion, 20 over x equals 25 over 15. You can simplify also, so 20 over x equals 5 over 3 when you simplify 25 over 15, and then cross multiply. 5x equals 60, 20 times 3, divided by 5, divided by 5, and x is equal to 12, or in this case, BD is equal to 12. So that's how I would have solved this one. Using the geometric means, yeah, you could, but again, however you see it, I think suffice. But they're all ratios. Alright, so that's the end of all your homework questions. I hope that's helped. I know it's a longer video. Fast forward, pause, do whatever you gotta do, okay? Talk to you guys on Monday.